just to get started, a bunch of people that normally show up to this thing are actually here,
Oh,
and they're currently in
yeah,
a
I
set, like a
figured.
road mapping session that like
Should we have done this
to
live?
do. So we could have done this live. Yeah. Well, so I've been
Live
basically
maybe
spending
fun.
3 days talking about IPVM, right? So I have been doing this live. Speaking of things live, what might be nice to capture on video, well, I guess we already have it on video though, is the demo. Might be interesting, but we already have it on video, so maybe that
Yeah,
doesn't make sense.
I mean, I was gonna do a little bit of a talk through, but today actually, but I was gonna have it be kind of audience based a little bit. So maybe it suffices to just do a more separated video going through it. If there's not going to be questions, but yeah, I was hoping actually I have it all prepped where I thought people would be on and we could go
How
through it. Yeah,
how
we could do that another time.
how loose is the schedule there, Brooke? I mean, like, would you know, would they be open to maybe having a live session with Zishan, you know, on video, and then just kind of take questions from the crowd? And
Well, they're
Could do
currently
that.
in the wrap-up session.
oh, okay, gotcha.
Yeah,
Yeah,
so
okay.
literally too late. Yeah.
Okay.
But I think they would have been up for that earlier in the week. It's a good idea. I wish
I
I'd
should
thought
have brought
about
it
it.
up. I could have,
I
yeah,
should
I
have
could
brought
have
it
done
up.
it
Yeah.
yesterday too.
Yeah, I gave
Yeah.
so we weren't on the schedule. They made half an hour for me to talk and take questions. So we got a little bit of IPVM stuff in there as well. But yeah, if we had thought about it earlier, they would have very much been up for that. But well,
Yeah, I mean, maybe we could set something up post, ad hoc.
Mhm.
I think if we want to do that, I think that'd be good. Especially if they were very interested, just gather those people together on a call
Mhm.
and set it up. Yeah, the other, I guess, bit of news was Brian got in the big process collector metrics PR. And the thing I want to say on that is not only is it metrics for us running nodes, but and for anybody running nodes that want to dump off metrics, but the same collector metrics will be used essentially for capabilities because we'll have access to. We don't do GPU yet, though. I think that we'll actually have to add that to the ticket. But CPU, memory, disk, it also can help a lot with knowing if a node is busy, and even though you've chosen it for a workflow. So I think it's really great work. And Brian dove in and with a little bit of pairing and some questions, but just did it, and that's awesome. And now it's working on the P2P and the beginning of network metrics and the beginning of network testing, because we figured the only way to actually test the metrics was to have a multi-node integration test. So we'll actually be running up multiple home stars as part of the integration test. What other? Don't I have anything else? I don't know if Brooke, if you want to. We're road mapping in the open. I don't know if you wanted to say anything to that officially. People can see it, so it's not. I know people go like surprise, or something. But
Well, it might not be a terrible idea for us to pull that open and screen share it. How far did you get in the star map? Or
I'm
should I
like
just pull up my
I
PR?
have everything. Yeah, if you want to pull up your PR, I think would be good. I'm about a quarter of the way through the star map. I'm rewriting issues as I am going through them, hence a little bit more work.
Yeah, thank you. Here it is. Okay. Come on, new window. No, okay. Thanks, Firefox. Here we go. All right. You all see this? Yes, awesome. Okay. If Zishan's seen this, we went over this live in St. Louis. And is in fact breaking things up. So thank you very much, Zishan, for taking a bunch of that stuff on. This was sort of like a reevaluation of the priorities and how far we are with different things, and have we learned anything? Has the plan changed? Essentially, first draft of this was in Figma. I can pass around the link for that as well. But this is kind of the broken up sort of here's sort of the tasks version of it. So phase 0 is mostly done already, right? And this covers a lot of what's in the IPVM grant as well. So the grant that we got from Protocol Labs is in two parts. First part is the actual I guess it's in three parts. Part one is specs. Part two, implementation. Part three is like documentation and support and like sample apps, things like that, right? So this is most of those first two, basically. So we don't have a complete bidirectional interpreter yet for with iPild, for example, right? Like it's in progress. A lot of it works.
It's an iterative project anyway, but yeah, for sure.
And there's a lot of interest in that here. A bunch of projects adopting WebAssembly. How do they interoperate with IPLD and WASM and all of this stuff, right? Like what should the IDL be? What's the ABI? All these things. Networking basically done, execution basically, or WASM execution basically done, scheduler, etc. And then also now trying to put in stuff that's not just like in the raw technologies, like how do we actually distribute this? How do we get this in people's hands as well? Phase one, we might actually end up breaking this into like two because it ends up being quite a lot of stuff. We were talking about that the other day, yesterday, the day before. So it's user account service that Philip is working on, and actually integrating the specs and getting the specs text fully up to date, this kind of thing. Developer experience, templates, onboarding docs. Can we have a front end demo, right, with React? Getting the nodes actually wired up on the network. Data and state effect. So
I should say they are wired up, but we need just thorough robustness, as I always say.
Robustness.
And that's really about testing. Yeah, for sure. A lot of edge cases with peers, obviously.
Yeah, well, and stuff will come up as we get deep into that. Data and state effect is interesting, right? So we know the set of what I've been calling first party effects that we're going to ship. But the first one that makes the most sense, and that is in fact part of that grant I mentioned earlier, is being able to read and write IPLD data out of a block store. And so we know roughly how that will work, but we have to actually implement it, right? So post block store that'll probably
And I was saying in the issue, so I actually have it as like there's like a parent. It's not in star maps. It looks as it's like separate issues because there's children, but they're essentially like a parent issue that has each of these as also separate links into their own issues. Because as we talked about, and Brian and I have discussed, this is actually probably be a lot of Brian's upcoming work. Has been we can actually, if we think about staging in the host part as like part of a workflow as it comes in, where today we fetch over IPFS, we don't do store, but instead we're fetching either from other Homestar nodes directly or IPFS. It doesn't really matter for those WASM modules, but fetch them as blocks and store them. We can actually do this part in WASI as well, with a SQLite implementation and a block store implementation. Those can work together. A very good example of this is in Fermion Spin, where they have a SQLite with interface and implementation. They have a key value with interface and implementation, and they can actually compile these together to create essentially a key value SQLite. And they use the same key value store for like a Redis backend, so you can actually see how that composes pretty well. And so this gives us the ability of and I put there's some questions to, I think there's separation, but also some reuse, hence why a larger issue and then separate issues where we might have to take off on specific things. But I think a lot of the general, the idea of having a key value stored backed by SQLite that can work for IPLD blocks and then other state eventually as well. I think there's a lot of shared code in here where there might be obviously some specific differences, like the streaming piece of this, which is a separate ticket as well in the star map stuff coming up. But yeah, I think there's a lot of niceties in terms of how we're going to be exploring this.
Yeah. So something we had talked about was having essentially a separation of like read and write, which is sort of like the classic separation for this stuff.
Yep.
And the SQLite stuff Zishan's talking about is at least what I've been terming session storage. So like it doesn't live past the end unless you explicitly say, please persist this at a location, right? So it basically lets you like take a bunch of state and put it
for the guest. We should say that's for the guest.
For the guest
piece of
yeah,
this, right?
Exactly. Yeah. So basically, it's you take some state that you're working with, put it off to the side, continue executing, then pull it back out again, right? If you need to. And then they get isolated per task, right? Because SQLite, you just create these files, put them in memory, whatever, right? So it's like it actually kind of has sandboxing built in, which is pretty nice.
Yep. Yeah, we would have multiple SQLites essentially for the host and for the guest. And for the host, obviously, that's mostly right now for WASM modules, related to blocks related to WASM modules. That's pretty much the main host case. Go for it, Brent.
A question about the guest use case. Would that be like if a guest wants to access state across workflows?
Yes, not across workflows, across tasks.
Within a workflow, across tasks.
Oh, okay. Okay.
Yeah. So you have a WASM function that. Go for it.
I was going to say, instead of session storage, maybe we should call it workflow storage. Maybe it's clearer.
Sessions have connotations to other things. Yeah. No, it'd be like workflow storage. Like first task will write some data to the store. Then there's maybe some other work that happens, and then one of the tasks later uses that from the store to do something else, and then maybe send it elsewhere after it's been updated, right? Obviously, you would hope send it elsewhere. Obviously, in different forms of this could be connected to like a volume of data. That's a little bit more toward an idea of like I have my data persisted and I am I am dealing with that or paying for that somehow, and I want to run workflows that update that, like my image directory or something like that. So you could see where that could be used in a view like that, but it's a little bit of a different than the generalized workflow setting.
Does this introduce effects in the middle of workflows?
No.
Okay.
No.
Yeah, because we immediately then run into non-determinism, right? Unless we want to start scheduling in a specific way. So we have to split these out into separate steps. The difference between this and IPLD is IPLD, we can get a content handle with a specific route, and we know that that's static.
Gotcha. Yeah. Great.
Yeah. So the other way to handle this is to make the keys and the key value scoped to some immutable reference that references content, something we could talk about. But I don't know if that's like people essentially, I think what they want in this isn't to pass around a reference, right? The point of having key value state is that you can just get whatever happens to be in there right now. And so if we have massive fan out and they're all writing, we could force that to have a deterministic, thing, but like it might not be, how does that also work? Like, do we have to do consensus across all the runners? Does that force it all to be on one machine? Like some of that stuff gets tricky, right? And so having a breakpoint of saying, okay, I'm going to persist this stuff, I'm going to read this stuff, makes that coordination a little bit easier by separating it out, even if it's less convenient. The way I've been thinking about this more recently is handling the ergonomics of that at the level of the DSL, right? And so like have a JavaScript DSL that compiles down into a workflow and that does the separation, right? Because we can build a control flow graph, right? At the extreme, you have like, one line per task, right? But like, that's not how people normally write code. We can rearrange code because we're not giving people
Homestar itself can also rearrange it. Just what you need is the incoming graph that the user has dictated essentially their dependencies, and exactly.
Well, and I mean the DSL can rearrange execution as well, right? Somebody
Yeah.
was, oh God, who was talking about this? Somebody recently was talking about like, hey, I have this DSL for doing basically this, and I wanted to compile down to different backends. And I'm like, this was that strange loop. And I was like, we should talk, you know? So, yeah.
Yeah, but yeah, to Brooke's point, there's a way to handle this where we can do it in a deterministic way. Obviously, the general state effect, if you're not dealing with SIDS or something like this, yeah, that's a different story a little bit. But
yeah, well, and you know, if you don't
KBC.
need the workflow to be deterministic, which like workflows themselves aren't, right? Like they're going to read from the world. Then you know, literally whatever. Yeah, it's when you want to interleave things in the code that's tricky, right? Because now you're going to have either you could treat the code block itself as being non-deterministic, but if you want to do verification on it, then we need to have the deterministic subset for as much of it as possible.
Yeah, exactly.
Yeah.
But idempotency we can get
Yep.
for this. So.
Yeah. Yeah.
Yeah, I don't know if you want to go next, but I guess resource limits.
Oh, yes, sorry, yeah. Yeah. So do you want to talk about this a little bit? So I should also mention the gear next to these, because these are in progress.
Yeah, I should have put that in the footnote. I mean, there's all gonna be star mapped anyway. But yeah, essentially we've done work on time and memory already. There's actually tests that do this. There's fuel metering has like some unit tests. You can't, you know, if you run out of fuel, it won't let you execute. The erroring is not great on this. Obviously, it's a whole different backlog piece we have to put on about really good error semantics here. It's like a huge set of work, but anyway, you know, we just need more robustness around testing fuel, you know, and how that threads through in a workflow. There's some questions to if you're controlling fuel within a task versus a workflow that gets pretty gnarly. You know, we're going to do the workflow implementation of this first once we have the global stuff that Human is working on. And that will be great for workflows, and that makes a lot of sense because we thread that through. But if you have like a task where you said, no, the fuel has to be, I only want to use this much fuel for that task, but the workflow is already below that. I mean, it's not necessarily hard. It's just, you know, you're dealing with like check the task. Oh, they wanted to do this. Oh, I already did this, you know, like, and without thinking about rearranging things to like try to operate within people given, you know, that's more complicated. So, you know, simple way, it's sorry. More complicated way could be like trying to reorder stuff, or, you know, maybe conveying something to a user about reordering, or changing what you expect from the fuel that you've given it, gas given it. And obviously this would be tied to other things, right? Like could be tied to payment and stuff like that. So
yeah, that's a good point though, because having those two different levels are kind of slightly different use cases, right? Like,
yeah, I would say the workflow one makes the most like immediate sense, and probably per task will be like a different thing to tackle.
It does and it doesn't, right? This is what I was just thinking through. As soon as we start breaking things up across the network, how do you know what to allocate to each runner? You don't know.
If someone else is running a task, that's correct. Yeah, that's right. That's right.
Yeah.
But
so
you have but yeah, and then you have to keep track of the entire workflow to know that. I mean, I guess it would be, we scheduled that other task. You know, depends on the pipeline. You know, what they're awaiting, right? So if you run a bunch of it on your node, and then it's like, now we need the answer of that and that to go to this other task that's going to run on this other node. It's like, but we don't even have enough fuel at the end of this where we are in the workflow so far, we're not going to send it. So therefore stop, you know, so it's something where the compute, I think maybe we could do it without like coordination of that state as well, essentially. The question, yeah. So anyway, haven't like thoroughly thought it through. Doable, but it's a great point, right? Like, yeah, because other tasks might run elsewhere, but whoever gives off the task, then it becomes the question of should I even continue this? Yeah.
Well, you can imagine. Sorry, Brian. Before, you can imagine a workflow that has no data dependencies. Like there's no flow in there. It's just a bunch of parallel tasks that have a single global gas counter, and that they get scheduled on separate machines. Now what? Right.
Yep.
So, yeah, that's going to be hard. So in some of these
and that's
cases,
obviously not the
effort.
compute over data. That's not the that's not the compute over data case, but this is the parallel. This is like the ray tracing case, right? Like, of course.
Yes. Yep.
And that's why I'm saying that's why I think that model, it wasn't the model I think we had with the original intention. Task running elsewhere, for sure. Workflows running in different places, for sure. Now, take this thing that's parallel and actually run it on a bunch of machines. But then, I think it's one of those things where, maybe, you might have to do some work to say after the first one completes, how much did that take? And if it's like, I guess the question is, you have to do some analysis to kind of say, should I stop everything else because we're going to run out? Or
but you don't know that, right? Like, let's say that has a fan out of 10.
Right.
One of them takes 99% of the gas, and the rest of them take
10%.
$10.
Sure,
Who knows, right? So we might have to do some.
So I'm saying, like, the best effort could be if you get the 91 and you go, there's no way. I mean, maybe doing some knowing what the other compute might be, you can say, hey, the rest of your tasks just stop in the middle. If you finish, you finished, but we're not going to complete this whole thing, possibly, right? Like
it could send a kill.
That's what I'm kind of getting at.
Right. Yeah. But again,
not that we didn't do extra work that we maybe shouldn't have, right? That's obviously a window that comes in there. Yeah, for sure.
Yeah. So we might need to, do some reputation tracking or something for this case, right? Or some economic incentive. Or like, 9 of them use 1% each, and the last one uses 85%. That 85% one will infer that the rest won't work, but that's still under the limit, right? So they may need to coordinate with each other and be like, hey, here's my receipt, here's how much gas I used, and then they can abort if they know that it's going to go on too long, but we might have to handle this after the fact, right? Ultimately.
But hence that parallel machine mode, running in parallel on the same machine, fine. Parallel machine mode, I think that's why I think we have to make that almost like a separate implementation. I mean, it's obviously integrated, but it's like a thing you have to like know about somehow. I think it's essentially.
The other way we could do this is with a validation step and enforce, like, there are edge cases where you don't want to do this, right, for efficiency reasons, but we could say that the gas in each task must equal the total gas if you have a global set as well, that those two numbers have to be the same.
So we could do this through like essentially the intention of the user. I agree with that completely. That's
because it's nice to have the global thing and say, like, one of these will take long, one of these will be short, right? And like it'll get in.
This is where I feel like and this is not to be on personas because I've just been thinking about that all day, but this is where it's like that's definitely like a very much like a person who's done a lot of development thinking, who's going to run that workflow versus like, I just want to run some stuff. I'll put some gas on it.
Exactly. Yeah. So anyway, we're thinking about it.
I was going to ask about,
go for it.
I was going to ask about estimation and like fuel estimation, which I think we've kind of been around the edges of. About like stating user intent, but is that kind of like, like a user might say, I only want to spend this much fuel, but do they have any idea if it's going to be enough? And another point, but
so the short answer is that they can get a pretty good estimates, and sometimes it doesn't matter, right? So you can get an estimate by just running it locally and being like, this thing's usually about 10,000 gas, right? Or whatever. Fuel. Sorry, we should use fuel. I've been saying gas all week because we have gas here, right? The other way to say it is like, I'm willing to spend up to $10 on this job.
Yeah, you spend more. This is like, yeah, I mean, this is how like when we were at BlockFi, BitGo, who was our custodian, they would actually we would send them a transaction essentially that they would offer on our behalf, and they would add, you paid them for this, right? This is part of the payment model to them as a company. They would add extra gas just to make sure, right? And then they would settle things later if there was any extra, but they would add extra gas and they would charge for that thing. And so we had to have, and this is something you can imagine we're doing. So if you're using the same WASM modules with different inputs, we could actually keep track of like typically how much gas did that stuff use. Like what we did at BlockFi is we had a separate service that, this is obviously much more chain related, cryptocurrency related, but like we had a process that would gather data from Etherscan and like whatever the 7 different things, and then would try to do averages and stuff to figure out what are the best times to, because we stopped using their service and started inputting our own gas in the configuration for a transaction. And so then it was like, yeah, what is the best time? Yeah, like all these things. We did a whole sheet of this that ran, and then like would come up with some heuristics to do that. So that's how we did estimation that way, for example. That was obviously on the user end. BitGo does not provide that service.
Yeah. Well, like definitely not in phase one, right? But just
right. Yes.
thinking about this kind of like in the open, just briefly, doing cost estimation is not like outrageous, especially when you have a well-defined schedule, right? Anytime you don't have control flow happening, you have certainty, right? So this block costs this much to execute, and it's in a loop. So that means that based on my inputs, like it's going to grow at with this curve, or hey, there's a branch. Well, it's either going to cost me 2 or 10,000, right? So you can do a little bit of estimate like that as well. But like one of the nice things is, especially if we have a registry and these things get run a bunch, we can tell you, hey, we estimate this will cost this, right? Which is kind of nice. And when you look at something like AWS, like on Lambda, you do get charged for time. You get charged for indications in time, right? And you can put a timeout on it. And what we're saying is like gas is or fuel.
Timeout,
myself,
essentially.
Is a timeout abstracted, or is this same things like how long did the Lambda run for? You're going to get charged for that in however many milliseconds, right? We're saying, well, we don't know the hardware this is going to run over, unlike Lambda. So this is our abstraction. So it is a timeout with payment, really.
Yeah.
Right.
How much are you willing to pay?
Yeah. Is there is there a way to build in sort of reserved rates at an upper bound? Like, we know this workflow won't cost more than this. And somebody can say, I'm just going to put the max money into it because this is mission critical and I don't want to retry.
So yes, but like without doing heavier analysis, there's the halting problem. So even if on 1 million runs, this thing has, had very nice performance, there could be a bomb sitting in there. They could be like, hey, if you put in these specific inputs, I will run for 10 hours, right? Like,
yeah,
who knows, right? You can check there are subsets that aren't susceptible to the halting problem. Basically, you don't have jumps, and then you know that it will finish in finite time, right? And there's a whole class of these. And then you can get actually very, very, very good estimates. We did a bunch of this analysis on EVM bytecode, and there was like a lot of stuff that you could get actually like very accurate in advance. And you know what? In the end, nobody gave a shit.
Because that's what I gathered from working in that world too.
Yeah, because like at the end of the day, they're like, well, how much is running this job worth to me?
Yeah.
Right. So.
Cool. Another thing sort of on this topic is let's say that you say I'm willing to spend X, your workflow doesn't complete. Is there a way to kind of like grab the state of the workflow and give you a chance to pick it back up where you left off?
Yeah, I mean that's the whole
Uh,
replayability part, right?
Not just replayability. I think you mean in a single task, right, Brian?
Well, either or. I mean, I could see like you know, workflow has 8 tasks and you get to task 5, and you don't want to pay for the 5 previous ones, you know, so it's not like a full retry or whatever. Yeah.
Right. Yeah. Yeah. So the short answer is that we failed halfway through a workflow. I think that works today. The version where, let's say you have a single WASM function that runs for 10 minutes and you get to 5 minutes and you run out of gas. There's absolutely no reason, like, I don't know if anything exists for this, but like in theory, there's nothing that says that you can't say suspend. Hey, user, do you want to add more money? Like, you could do that. I don't know if anything supports that today.
Yeah, I mean the problem is there's not really a great like resumption model, right? Which you essentially want is like, I'm in a continuation. I'm gonna come back for an answer, and then I'm gonna come back and run the rest of the code, right? Yeah, for sure.
I mean, literally, freeze the VM state as it is with all of its memory and everything in place. Don't persist it. This is like a temporary suspension. We're gonna run on this machine again, right?
Yeah. You wouldn't do this in a home star that's running multiple workflows, probably, right? Which is the problem. But you could do this. So like when we looked at this thing called Crick or Crit or Crit or Crick or something, it was like we looked a lot at like preemptive, like how to do like actors as dockers, ephemeral Docker nodes that can do preemptive state. This is the idea we had at Comcast. And so this was the idea, right? So like each of your workflows, we also had workflows, would run on its own container that then we could snapshot the state of that container, but there was nothing else, right? I mean, we looked at unit kernels first, right? Obviously it's how that works. And you're like, yeah, but probably not. And so having this ability to do like run things that way. So the problem is obviously in a home star node, you can capture the state of it, but not like the memory, the system memory, and all those pieces that what we will do, to your point, Brian, and we already have this a little bit planned with workflow state, is you could, at the point of that failure, you want to know what that workflow is. We already have workflow info, it's just adding to that. We would have the state of the gas, how much gas was left, how much time was left. So we would have all that information. So when you replay, you still have to like replay on the receipt. So it's not like resumption, but you would have all the state necessary to know, like, you don't have to give me a whole new thing of gas again.
Yeah.
If it's the same exact workflow, obviously if you modified it, that's very different.
Yeah, so it sort of softens the blow of an off estimate.
Yeah, but I guess
I should put that in
if it's a longer running thing. At which point, Docker might not be a terrible thing to put it inside of. I guess you could also suspend resume if you were doing it interpreted, but we don't want to run things interpreted, right? So.
Right, and I haven't seen anything like in the. I mean, I haven't seen anything specifically with those hooks in the interpreted WASM stuff per se.
Yeah.
But yeah,
it's almost like a step through debugger feature, right? Like,
yeah, I mean, obviously with Docker being able to run WASM as well, and there's some stuff, obviously a lot of stuff going there. You could imagine. I mean, this is a little different. This is not compute over data, where it's like we know the the node has that data. It's kind of like more pure compute. If I'm going to give you the data, which you would do in this Docker case, I'm going to give you the data and I'm going to spin you up on demand. Like this would be something you could do in Kubernetes, right? Where you're like, I want to spin up that node on demand and shut it down. This is like truly like Lambda. We could actually look into that, right? Obviously, it's a little different. It's obviously then the Homestar coordinator is spinning up, and that means the orchestration work we would spiral. We're full Kubernetes at that point.
Yeah,
not like what I've been calling little bit Kubernetes.
yeah, this is like extremely K8s. Yeah, I think we put this in the bucket of like being able to suspend resume within at the granularity of a workflow task. Probably like I agree with Brian. I think it's probably sufficient for most things.
Agreed.
If people start jumping up and down and screaming that they need this other thing, then we can explore it then, right?
Yeah, give me yeah. But I actually I'll put that into, I think that's like a phase 2 or phase 3 thing that I think is really important. So that's a good one, Brian. So we don't run out of time. I guess we should go through more. I don't know. All right, Brian, did you have any more on
Nope.
that?
Well, yeah,
Cool.
just I guess at a really high level,
Yeah.
observability, task permissions, like updating to the latest of validation and VARSIG, deployment stuff, basically James tasks. So making it easy to deploy to cloud services, having all of the nice graphs set up, all of these things, right? Phase after that, we start to set up the more general first-party effects, HTTP, get, put, post, the idempotent randomness oracle, deterministic randomness, having truly distributed scheduling, networking. So we're just setting up an IRO node now, and so we'll see. Like we're network agnostic, right? So like we should be able to serve over both.
And as discussed for recording too, not only agnostic to both, but probably the possibility to use both simultaneously. Like we get discovery out of the P2P, for example, where we wouldn't.
Yeah, exactly. So IRO doesn't have things like DHTs, right? So they did a bunch of research into it, and they're like, you know what? That's not the thing we need to solve right now. Maybe sometime next year, right? The big advantage on IRO is they've lifted almost not even almost exactly. I think it's exactly what TLScale does for NAT punching, and so that will really help with consumer devices that sit behind NATs, right?
And they have a benchmark against the hole punching stuff from the P2P.
I mean, in that it actually works, yeah.
Well, I mean that their performance
Yes.
of this is better than what the P2P
Yeah,
offers. Okay.
They measure basically everything, and they always compare against P2P/IPFS. So I would assume so.
Is there is that available somewhere?
Yeah. I mean,
That one
I've at
post I
least seen
saw.
it.
Okay.
Yeah, I've at least seen it in talks that they've given. Ping B5 and ask, and I'm sure that you can get, or like drop into their Discord.
Okay.
Yeah.
Good deal.
Yeah. Services at that point, task registry. So we're assuming that most people will consume, and there'll be a smaller group of people that are writing tasks, except for glue code, right? I think glue code people will still end up writing. So task registry and a dashboard, right, to plug into the accounts from the previous step. Settlement, so people should be able to get paid for running stuff. So help from plug in Stripe. And then do the IPVM, IPFS support, Kubo run command as well. And then it starts to get a little bit fuzzier when we get to phases 3 and 4, right? But that's like actually relatively far out, which is what I was saying earlier on about like, man, phase 1 is pretty big. So Zishan and I were talking about breaking it up.
Yeah, that's good. Yeah.
But it's also one of these things where, the further out you get, the fuzzier the picture is. We're going to learn a lot between now and what's currently listed as phase 3, right? So I'm actually relatively comfortable with, if we break up phase 1 a little bit more and sort of, put weighted priorities on that. There's obviously a lot more effort going into IPVM now. So there's more, we're going to be pushing more of these faster, right? Than we have the past year when it was Zishan was bench pressing the whole thing. We now have 8 people bench pressing this thing, right? So many hands make light work. And yeah, so that's basically where we're at with this. Zishan is putting into star maps. So we'll have a nice high level view that we can like drill down into. Yeah, and anything else you want to say about that, Zishan?
Yeah, there's a few smaller issues that are not in this roadmap that came up just yesterday. As I was going through this, I'm like, oh, we should tackle that. There's obviously enhancements as well, which won't be put into phases that we'll have to eventually phase in. And we'll have to, I think we'll be doing internally, I imagine in one of our engineering pods, kind of a run through on what the ETAs and some of the stuff that we're going to attempt for on these. I didn't put them all down. So if you go to the star map, it's like, I don't have that data. I'm going to put a fake date for now, but like, we're still discussing this internally in terms of how we want to best roadmap this in practice. Yeah, in terms of new stuff, there's not too many. I think there was just like one or two things that came up, and obviously the one Brian brought up is a good one to add in here. And so yeah.
I do enjoy that what we're doing is finding the tendencies between tasks and scheduling them, and figuring out who has what capabilities to run them. Or sorry,
we are we are all IPVM. We are all
Very meta.
IPVM.
No, I'm IPVM. No, I'm IPVM. Amazing. Other stuff we want to talk about. Or, sorry, Zishan, you were leading this meeting before. I'll let you keep running this.
Yeah, I don't know. I think that's everything. I mean, really is putting all this together. You know, right now, you know, there's a lot of work from the folks at Fission and other pieces that are underlying this, like RS UCAN's getting a new face a little bit on the Rust, and I guess their whole WASM side. You know, Brian's been working on, again, what is the gear there for the P2P metrics, and essentially will be the same metrics we use for any kind of networking stuff. Actually, in the issue I've added, we eventually want to add WebSocket metrics, RPC metrics, all these things. But those are, you know, metrics are forever iterable, or irritable. They're both, I guess, if you think about it that way. Iterable. And yeah, I think that, and I'm finishing working on the interpreter stuff, also road mapping and stuff like that. Yeah, I think that's all the things.
Yeah. The other thing I'll say on video, I know that you all heard this in the Discord already, but people here are pretty excited about IPVM things. So I was not planning on giving a talk. They moved the schedule so that there was a space for an IPVM talk. Lots of questions. A lot of people who want to start using it and kick the tires, tie their systems into it. This open world assumption, which we've talked about from the beginning, but I think it's just now starting to click of like, oh, we could tie all of our stuff together if we just wrote a small WASM module. Like, yes, excellent. So I've talked to a few teams already about like, hey, when we have a plugin system, let's talk, right? You know, let's make you an early test case for what that would look like.
Yeah.
I mean,
we should. I mean, we have that ticket, and we have that issue. I saw it yesterday. We didn't put it in the roadmap. It's probably a later phase, but it is obviously a big part of what we're doing.
Yeah, I've been thinking a little bit about the design of that. Actually, this is maybe relevant enough for this call. I think we might even be able to make a standard interface, or like a couple of them, because really, what are we going to talk over? HTTP and Unix sockets, right?
Yeah.
We might just be able to make those two standard interfaces.
If everything works with our HTTP effect, I think we'll be in a good spot.
Yeah. And then you could imagine, you could then imagine using, like, having the host now understand how to do that for the one thing. You could essentially modify it so that you could get other like guarantees from the services that you're calling into to be like, hey, this thing is exact one semantics or whatever you need. But it uses, under the hood, it uses the HTTP effect.
Yeah.
Right.
No, I think that's right. If most things are speaking essentially over the socket, I think then you know, there's a pretty good story for that. If it's more, I don't know, if it's more something else, where it has to be like at the, you know, can't be done just more via a normal service, then that's, you know, a different kind of thing.
Yeah. Well, and from the point of view of a workflow,
the
sorry.
payment stuff and all that. But yeah, I was just saying, let alone like,
Yeah.
do you run that thing you plugged in? Gonna cost you a lot of money, whatever it is.
Well, and maybe that's fine, right? Like there's some, I agree, there's some pragmatics to figure out there, but from just like the raw technology, there's two sides, right? There's the outside world, there's the plugin module,
Yeah.
and then there's the normal workflow system. This interface is always identical. It has inputs and it has outputs, and that's it, right?
Yeah.
And on the outputs, it outputs a receipt, and that's it, right? So it's like very standardized. This other side, we have a little bit more play with, but most of them will be HTTP or Unix sockets, right?
Yeah.
So it actually becomes very simple, right? All that we need, this has to be fixed. This can move, but we can make that an easy template to adjust.
Yeah. I think obviously the
Yeah.
part that always gets to, we talked about in the past, is what is the the trust. Obviously it's an optimistic trust model to that, right? And
Mhm.
then you get into stuff that we actually I have to put back in here again later phases of like slashing,
Mhm.
your reputation,
Yeah.
freemium model, not freemium model. What does that mean?
Yeah.
Because that's where that stuff really comes into play too, right? Because when it goes over the socket,
Yeah.
unlimited pools, right? So you just have
Yeah.
to hope that it works. Yeah.
Yeah. Speaking of trust, really briefly, so I've been sort of like on and off for the past 6 months thinking about the interaction of UCAN and Eigentrust. And I actually think that there's a really nice, I think they play really nicely together, basically. So Eigentrust is, for the recording, is like a very well-known paper for doing transitive trust. So to say, I trust Zishan and Zishan trusts Brian. Like I trust Zishan 90% and he trusts Brian 50%. So I should trust Brian. I can't remember what the formula is, but whatever, 45%. We have the entire.
So it's not purely
delegation.
transitive, but there's like a lossiness, but it does have some formula that tries to convey significance of that. Okay.
Yeah.
Cool.
Yeah, exactly. It's weighted. And like how far away they are and all this stuff. It's very, very simple system. In the end, it's very elegant. And it's like cited thousands of papers. It's very, very highly cited paper. That depends on there being a network of trust, right? It's a graph. You know what else is a graph of trust? Delegations, right? So like I think there's a really nice, like they map onto each other really nicely.
So it's like weighted delegations essentially. Yeah. Okay.
Yeah, to kind of be like, well, I see a lot of good stuff coming from them. I should probably trust them. Oh, they sent me some bad stuff, but it was just one time. Like, how bad could it be, right?
I think that's how we've been thinking about it more, heuristically. But I think, to your point, there's a way to like semantically implement this. I think that's a good approach.
Yeah. Yeah, and then all the slash and whatnot. I mean, that's non-trivial. We may want to plug into an existing system for that rather than build our own.
Yep.
Yeah.
100%.
And like, what's the exact remedy for things that are they sent an email but they sent something horrible in the email. Like you need to really trust some of these steps, right? So, but I mean, email is a bad example because there's a mail server, right?
Yeah.
But maybe somebody earlier in the workflow, it's like, oh yeah, could you format this email nicely for me? And they start inserting like horrible things into the thing, right? Like, so all stuff we'll have to figure out as the system comes together.
Cool. All right. Well, thank you, everyone. I think that's good. Thank you, everyone on the recording, for hearing us pontificating. All right.
See you.
Take care, y'all.